winter break.
Okay.
Everyone just stopped.
Concavity. So concavity tells you whether slope is increasing or decreasing. So concave up, if I'm looking at the original graph, looks like a U. So concave up, starts the U. So if you're looking at an original, and this is where we start to get into the levels of. So the first thing we're doing is I'm going to give you an equation like those three on the side over there. We're going to go through in a second. You're going to find where it's increasing, decreasing, relative max, relative min, concave up, concave down, points of inflection, horizontal and vertical asymptotes, and you're going to put all that onto a graph. So the point is, can I give you an equation, take away your calculator, and get you to make a graph that looks exactly like the calculator would? Then we start looking at graphs. So I'll give you an original, a derivative, or a second derivative, and you got to be able to go back and forth and say, okay, well, this is what concave up means in this level, this level, this level. So we're going to kind of start talking about both as we go. We're worried more about the graphing right now. I'd like to be able to take this and put it on a graph, but we're also heading toward the other stuff. Yeah, I'm just going to leave it like that for right now. So concave down. Concave down, it's got that N at the end. F of X looks like one of those two parts of the end, of the N. So if you think about it, every graph is either a line or it's like made up of these parts. Like every graph is either a wiggle this way, a wiggle this way, a wiggle this way, or a wiggle this way. Or a line. That's pretty much what the graphs break down into. If we switch, so a point of inflection happens when we switch concavity. So that would look like that, or that, or there's a couple other ways, but that's a general idea of it. So here we've got like the downward part of the N, or that's part of the N, so we're concave down in this part, and then all of a sudden we switch to, it's curving upward, so that second part is concave up. Here we're concave up, and then we switch to concave down. Questions here? Can I move on from this, or is everyone still writing this stuff? You're still writing? Alright, so if I give you an original graph, say this is f of x, something like that. You should be able to hopefully tell me where it's concave up and where it's concave down. And then where there are points of inflection, I'm just going to write POI. And if you're looking at a graph, you're estimating. There's not like a precise way to look at a graph and be like, yep, right there it changes, but you should be able to get pretty close. here, that's supposed to be like all one. So that's a 0. That's a 1. That's 2. So you're basically looking at n's and u's. So the graph is going to consist of those two things, and you're just trying to identify like where you see which one. So we've got an N shape, I'd say up until 0. Like that part looks like an N, that's concave down. So you're concave down from negative infinity to 0. Because it's all the way over, all the way to the left. And then up to 0. And does 0 make sense to you guys that that's kind of where it switches from N to a U? Do you agree with that? Yeah. So then it's a U from, I'd say from 0 to 2. So then we're concave up from 0 to 2. And then it flips back. I think it's the last one because I'm out of colors. And that looks more like an N then. So we're concave down again from, oops, that's not how that goes. We're concave down again from 2 to infinity. So where are the points of inflection? Are the x values where they switched? Well, we can do y values too. There's a point of inflection at 0, 0. There's another point of inflection at what? 2, 0. So it's these two guys because that's where we switched from an N to a U or a U to an N. Alright? Questions on that? Can I erase? Alright, so let's start going through like algebraic. Let's take this number 1 over here. Y equals 1/3 x to the 3rd minus 1/2 x squared minus 6x plus 8. And we're going to go through and find where it's increasing, where it's decreasing, where there's relative max, where there's relative min. What level does all of that information come from? Original, first derivative, or second derivative? First derivative. So this stuff all comes from f prime. I should have also put horizontal asymptotes and vertical asymptotes. What level does that come from? That comes from f. And then we're going to find concave up, concave down, and points of inflection. And these come from f double prime. And then at the end of all this, which we're not doing today, we might start tomorrow, if not on Wednesday, we're going to take everything and put it together and make a graph. And then you're going to have a quiz soon-ish, it could be by the end of the week actually, where it's just like 2 of these. I ask you to do everything, find everything on there, give me all the information, graph it. But asking you to do more than 2 problems like that in 50 minutes is just probably too much. Maybe 3, we'll see how it goes. Maybe I'll give you 3 and grade your best 2 or something like that. Okay, so are there any horizontal or vertical asymptotes in this? No, why not? There's not a fraction, right? There's not, because you have to have an entire top and an entire bottom. And you got fraction coefficients, but that's the entire formula is not a fraction. So there's no horizontal asymptotes, no vertical asymptotes. So let's take the derivative. So y prime equals x squared minus x minus 6. That's why the original equation looks so goofy, so that the derivative could be normal. What do we do with the derivative then? Set it equal to 0 and solve. So I'm going to try to factor this. So multiplied at -6, add up to -1, we do -3 plus 2. So I get x equals 3 and x equals -2. And this is all just review from the stuff we did last week. It's just part of the process to get to the stuff from this week. So we get our intervals from -infinity to -2, -2 to 3, 3 to infinity, and where do we plug back into? Plug into the derivative. Whatever level you're at, that's where you plug back into. So when I'm at the first derivative level, I'm going to plug back into the first derivative. That tells me slope, so it's going to tell me whether I'm increasing or decreasing, and then I can get relative max and relative min. So if I plug in like -10, I'm going to use this. -10 will give me a negative number there, and the negative number there, so f prime of x is positive, which means f of x is increasing. So we're increasing from -infinity to -2. If I plug in 0, this is negative, this is positive, so we get a negative derivative. And then f of x is decreasing, so decreasing from -2 to 3. If I plug in something between 3 and infinity, let's say 10, everything's positive, so now the derivative is positive, which means the original is increasing. So where's their relative max? What's the x value of the relative max? -2. When the original graph switches from increasing to decreasing, you get that top of a hill. So there is a top of a hill at -2 because that's where that switch happened. And then typically you would plug back into the original. I don't care. I don't want to do that. I don't care. Those fractions, I don't want to worry about it. I know how to do that, but because I want to get to the next part. So the relative max at -2 comma something. If I wanted to find this y value, where would I plug back into? Which level? The original level, right? At 3, we were decreasing until that. We're increasing after. So we get the bottom of a hill. So there's a relative min at 3 comma whatever. Like as we're doing them for real and graphing them, we'll find the whatever. I just don't care right now. So there's a relative min at 3 comma something, a relative max at -2 comma something. That's what we did last week. Question on that process. So the process for concavity is the exact same. We're just doing it with the second derivative instead. Exact same process. So I'm going to erase all this. I'm going to take the second derivative and I'm going to repeat that process. Except instead of increasing, decreasing, it's concave up, concave down. So my second derivative is 2x minus 1. I kind of forgot the first derivative was. Is that the second derivative? Okay. Set that equal to 0. And if that was a fraction, you would set the top and bottom equal. So x equals a half. So that's your critical point. You're going to set up intervals around it. Same exact thing we did with increasing and decreasing. So -infinity to a half to infinity. You plug back into the level that you're on. So I'm at the second derivative level, I plug back into the second derivative. Second derivative tells me concavity. So I'm going to plug like 0 in, because that's in this window here. If I plug 0 into the second derivative, I get a negative number. If my second derivative is negative, that means f of x is concave down. Negative second derivative, concave down. Positive second derivative, concave up. So you've got like an N shape over here. If I fill in my chart over here. So it's concave down from -infinity to 1/2. Plug in a number between between a half and infinity, let's say 10, to the derivative, 2 times 10, I get a positive number there. So my second derivative is positive. That means my original graph is concave up from 1/2 to infinity. And so a point of inflection is just when you switch from one to the other. In the first derivative level, it matters if you're going up to down or down to up. Why? Like if I go ink to deke and deke to ink, are those different things? Yeah, because max and min, right? One's a max, one's a min. In the second derivative level, it doesn't matter. If you're switching from concave up to concave down, it's a point of inflection. If you're switching from down to up, it's a point of inflection. So you don't have to worry about like max or min. There is a point of inflection at 1/2 comma something, and how would I find the something? Plug into the original. I'm not going to do that right now, but there would be a point of inflection at 1/2 comma whatever. And then what we'll do, again, either tomorrow or the next day, is put all that stuff on a graph and connect everything. So this right here, that's circles. That and that is like today's ones. It's the same thing as before, right? Just like in a different way. Yeah. Questions on this at all? Alright. Let's do second one. Second one's tougher. We got a fraction. So again, I should have left this up over here. HA and VA come from the first level. I'm trying to color code it this time. Ink, deke, relative max, relative min. Those come from F prime. And then concave up, concave down, and points of inflection come from F double prime. You guys want me to do it or you want to do it? Do you want to try it before I do it? Alright. Pause this and then. So horizontal asymptote with the highest powers are tied, so you look at the coefficients. So 1/1. We have a horizontal asymptote at y equals 1. Vertical asymptotes from the bottom equals 0, which is at x equals 2. Your derivative is the bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared, which will just end up being -2 over x minus 2 squared. When you said each of those pieces equal to 0, so -2 equals 0, well that never happens, so that doesn't matter. X minus 2 squared equals 0. Remember, the power doesn't matter, that's the same as x minus 2 equals 0. So x equals 2, so I get my 2 intervals kind of built around the 2. If I plug 0 into my derivative, I get a negative number on top. Bottom's always positive because it's squared. So this tells me that the derivative is negative, which means f of x is decreasing. So let me fill that in. If I plug in, say 3, still a negative number on top, bottom is still positive. So the derivative is negative, and f of x is decreasing. So it's never increasing. And if it never is increasing, it never switches from one to the other. So there's also not a relative max or relative min. Questions on anything yet? Should I wait to keep going or go ahead? Wait. Okay. Alright, so we're going to erase the first derivative and repeat that process with the second derivative. So your first derivative was negative 2 over x minus 2 squared. So your second derivative, I use product or quotient rule again. The bottom times the derivative of the top, which is what? Which is 0, which really helps. Minus the top times the derivative of the bottom. So I'm bringing down the 2, leave the little guy alone, reduce the power by 1, and multiply by the derivative of the little guy. And then all over x minus 2 squared. So that goes away. And you get 4 times x minus 2. Oops, this should have been squared. Over x minus 2 to what power? To the 4th? And you're totally welcome to leave it like that and plug it in there. For some of you, it might have been easier if you went, okay, that's just 4 over x minus 2 to the 3rd. Like you can cross off one of those. You don't have to. And you can plug it in, so whatever works for you.
Can I give her a message and maybe 10 seconds?
Yeah. Just do it.
She can tell you if she wants.
Okay.
That's the video.
So if I set the top equal to 0, nothing happens. 4 never equals 0. Set the bottom equal to 0, I get x equals 2 again. So I'm going to go negative infinity to 2. 2 to infinity. I'm plugging back into the second derivative because that's where I am. You're always plugging back into your own level. So I plug in like 0. 0 minus 2 is negative 2. Negative 2 to the 3rd power is still negative. Positive divided by a negative. Your second derivative here is negative, which means f of x is concave down. So we're concave down from negative infinity to 2. If I plug in, say, 10, then 10 minus 2 is a positive number. To the 3rd is still a positive number. So this comes out where your second derivative is positive. And that means your original graph is concave up. So from 2 to infinity. So is there a spot where the concavity switches? Is there an x value where the concavity switches one thing on one side and one thing on the other side? There is an x value where that occurs, but it's actually not a point of inflection, so this is kind of trickier. So I would start off by going, okay, that's great. There's a point of inflection at 2, comma, whatever. Because it does switch. It goes from down to up. That's point of inflection. How would I find the whatever? Plug back into the original, right? What do I get if I do that? I get undefined. Why? What's the problem with x equals 2?
You get 0 in the bottom. You can't divide by 0.
Why? X equals 2 is busy, right? It's like I already got a job. It's already a vertical asymptote. So at this point, you're going to be like 2, oh, wait a minute. That doesn't make any sense. It's actually not a point of inflection because it's already a vertical asymptote. You can't have a point on top of a vertical asymptote. So I know this is getting ahead, but I think we can start to look at what a graph would look like. Horizontal asymptote at y equals 1. Vertical asymptote at x equals 2. Over here to the left of 2, we are decreasing and concave down. So try to think about what that would look like. Decreasing and concave down. So it's the concave down is the end, right? Decreasing is the part of the end that is decreasing. So what does that look like? Like the second half of the end, right? And you got these asymptotes here, so it would fit in like that slot. That is decreasing because it's getting, it's going down and it's got that end shape. And you're not going to have to do this on tonight's homework. I'm just starting to talk. I'm just previewing, I guess. To the right of 2, we are still decreasing, but now we're concave up. So you got to think about what decreasing and concave up looks like. Up is a U, and you want the decreasing part of the U. So concave up is this U. You want the part of that U that's going down, and then you try to fit it in amongst the asymptotes. So it's decreasing because it is going down as a negative slope, but it's a U, that downward part of the U. So that's what that graph is. And that's a perfect example of like one of your test questions. questions on this anywhere? Can I erase? Is everybody still writing or anything? All right, one more I want to look at. It'll be quicker though. Let's say, so y equals x squared minus 5x minus 6. And all I'm asking you, I'm not saying graph the whole thing. I'm saying find where it's concave up, find where it's concave down, and find points of inflection. So I'm going to take the first derivative because I need the first derivative to get to the second derivative. But I'm not going to worry about increasing, decreasing, relative max, relative min, any of that stuff. So I'm just going straight down to first derivative is 2x minus 5. I want concavity though. Concavity comes from the second derivative, so I'm just going to keep going. Second derivative equals 2. So how many critical points are there? Like I'm going to set that to equal to 0, but that never happens, so there's no critical points. How many intervals are there then? 1. And what's the interval? It's the entire, so like if I have a number line, and I have one critical point, and I put that critical point out there, it splits that number line into 2 parts, right? If I have 0 critical points, I'm not splitting that number line at all. So the interval is the entire number line. So I'm going to go from negative infinity to infinity. I'm going to pick a point in between negative infinity and infinity. So you pick anything you want, let's say 0. I'm going to plug it back into the second derivative. Well, the second derivative was y prime equals 2. If I plug 0 in place of x, is the second derivative positive or negative? Second derivative is 2. There's no x there, so I don't care what I plug in for x, because there's not an x. Second derivative is just straight up 2. Has nothing to do with x. It's always positive. So if the second derivative is always positive, the original graph is always
Concave.
Concave up. Those are different things, though. So the second derivative is positive, which means the original graph is always concave up. Well, what's that look like? Well, what's that graph? It's just a parabola, right? So isn't that always going to be concave up? Like it just looks like a U. That's like the definition of concave up. So a couple things I want to make sure of there. If you're just asked to do the concavity stuff, skip all that crap in the first derivative. If you have to do the graph, you have to find it, but a lot of times you don't. Second thing is if there's no critical points, you have one giant interval. That's what I want to talk about there. Questions? All right, so there's